So today we are going to look at reflections and how we reflect an object. So yesterday we looked at translations, which was slides. Today we're going to look at reflections, learn how do we reflect them, and then how do we find the line of symmetry for those. So a reflection takes an image and reflects it or flips it over a line, and we call that line the line of reflection, or sometimes we even call it the line of symmetry. So this is going to be, some of it will be familiar to you. So here the Nittany lion actually reflected over that line. Okay. Unlike today's Nittany lion, he wouldn't slide for. Okay, so with a reflection, it does not change its size or its shape, but its orientation changes. So notice that the Penn State is written backwards and that the number 1 is held up on opposite sides. So when we are reflecting across a line, okay, we have a line of reflection. Here's my pre-image, and it's reflected over this line to give us the image here. Okay. So when we reflect over a line, okay, when we look at the line that connects the image and the pre-image, the line of reflection is going to be the perpendicular bisector of whatever it connects. Okay. So if I'm going to connect C to C prime, okay, the line of reflection will bisect it and be perpendicular. And that's going to become important when we look at some graphing some other things. So if I'm going to reflect over an axis, all I'm going to do is I'm just going to take point A. I can count down 1 to the x-axis, and so my A prime is going to be 1 over on the other side. My B prime, I go 1, 2, 3, 4, 5 places till I hit the x-axis. So I'm going to continue on 5 more places. 1, 2, 3, 4, 5. And that's B prime. C is 1, 2, 3 spaces above the x-axis. So I'm going to go 1, 2, 3 places below the x-axis. Okay, and there is my image, and it's labeled. Okay. If I want to check to see if this is my line of reflection, right? It's the x-axis would be the perpendicular bisector between point C and C prime. So we counted 1, 2, 3, 1, 2, 3, so these are congruent. And horizontal and vertical lines are perpendicular of each other. I can also reflect over lines like y equals 3. Now, when you did this in 6th grade with Mrs. Hogan, you only did over x and y axes, right? So now I'm going to reflect over the line y equals 3. So there's my line y over 3. So A is 2 units below A, so I'm going to go 2 units above. I'm actually going to change this color so we can see it better. Okay, and there's A prime. B is 2 units above, so I'm going to go 2 units below for B prime. And C is actually right on that line of reflection, so I don't have to change it. And I'm going to connect my dots, and there's my triangle. So my final is going to be in there, right? And it might be easier to sketch that if you were doing the fill it in if you were doing this on paper. All right. So now I want to reflect over the line y equals x. So that has a y-intercept of 0 and then a slope of 1. So here is that line right here. Now remember that I said that this reflection is the line of reflection is the perpendicular bisector between A and A prime. So if the slope of my line here is 1, remember the slope of my perpendicular is -1. So what I'm going to do is I'm going to follow along this line going -1. So it's going to go here to here to here from A. So I'm going 1, 2, 3.5 units. So I'm going to go a half and 1, 2, 3, and there's A prime. So that makes that perpendicular right here, and then these would be congruent. So with the C, following that slope of -1, I'm going to go 1, 2.5. There's my half, 1, 2, following the slope of -1, C prime. Okay, B, if I follow along, I'm going to go 1, 2, 3, 4.5 units. So I'm going to go 1, 2, 3, 4. So there's half and 1, 2, 3, 4. So my B prime is right here. I'm going to move that C prime so that we can see it better. So what I did, okay, was because the slope of this line is 1, y equals x, I'm going to follow a path along y equals -1, or a slope of -1. So I connect those dots, and I want to make sure that it's a bisector between this line. Okay, so this distance has to be the same, this distance has to be the same, and then my slope has to be -1. All right. So I'm going to erase this stuff real quickly because now I'm going to translate it, okay, using -3 and 2. So that means I'm going to go 3 to the left, 1, 2, 3, and up 2. So there's my A double prime. So B is going to go 3 to the left and up 2, my B double prime. C is going to go 3 to the left, 1, 2, 3, and up 2. So here's my C double prime, and my final translation is this. Okay. Right. So your textbook gives you these rules for reflecting. So if you've got the coordinates a negative b, or AB, if I reflect over the x-axis, it's going to be a negative b. If I reflect over the y-axis, it's going to be negative AB. If you're going to reflect over y equals x, you're just going to flip the x and y coordinates. And if you flip it over negative x, you flip them and you make them negative. These are okay rules to get, but I think it's a lot easier to just actually do the reflections rather than state the rules. But here they are in case you want to be a rule follower, which we all know a lot of you aren't. All right. So we, for right now, are actually skip that problem, and we're going to skip right to lines of symmetry. So when a figure can be mapped onto itself by reflection of the line, called a line of symmetry. So we want to see if these figures have what we call line symmetry. So can we fold onto itself? So if you think back to algebra, when you graphed parabolas, right, they had a line of symmetry that it folded in on itself. It's the same concept here. So how many lines of symmetry does each hexagon have? So if I was to take this, I would have a line of symmetry that would fold that in half. Very visual. So then I have another, if I put it in the middle, that I would have a line of symmetry. And those are the only places you're going to have a line of symmetry. So this one has two. For this hexagon, if I go from here to here, I have a line of symmetry. And if I go from here to here, I have a line of symmetry. It will fold in half. Okay. So I'm going to have, I go from this vertex to this vertex, it will fold in half. Okay. So right now I've got 3. Here to here is another. So I've got 4. So it might be easier to see if I go from here to here. There's 1, 2, and 3. So there's my vertices, right? And now if I go in half, there's 1. If I go in half here, there's 1. And if I go in half here, there's another 1. So this actually has 6 lines of symmetry. Okay. This hexagon only is going to have 1. I can only fold it in half if I go through those 2 vertices. Okay. So there are the different lines of symmetry. I can take those hexagons and I can fold them in half. So today we talked about reflections. Yesterday we talked about translations. Today we talked about reflection and how we do reflect a geometric figure. So when we look back at those reflections, we didn't really talk about that, but if I reflect, say, this triangle or this diamond over this line, okay, it doesn't change its shape, but it will change its orientation like it did the Nittany lion, with one little hand sticking out here and one hand sticking out here. But because the sign doesn't change, it is a nice symmetry. All right, so have a math-tastic day.